my name is Avi Cavale. I'm one of the founders of Shippable, and what I want to talk about is the most exciting thing that's been happening in Docker in the last 4 weeks since we had the last meetup, and that's how I'm going to start. And then I have a talk about what we do at Shippable in terms of declarative YAMLs to do deployments, and then we have 3 more talks after that: one from Tune, one from I think it's Open Mail, and one from I walk with agenda. So in terms of first, thank you to Fortune. They let us use this space, and this is an unbelievable space. We have like chefs and beer and everything. I mean, so I'm always excited about this. So just a big thank you and a round of applause for Tune, please. So in terms of the agenda, we're already a little behind. I'll try to speed up as much as I can. And as I mentioned, 7.10 is Tune's Docker platform. They've been using it for quite a while. Nick is going to talk about it. There is running developers on Docker. DJ from Open Mail is going to talk about it. And Swarm CI, Wes is going to talk about it. He was one of the Docker Hackathon winners. And so in terms of what's new with actually Docker, this is a big deal. Just a couple of weeks ago, Windows Server announced native support for Docker. And it's exciting for us from a business perspective because we couldn't address over 60% of the market because they were all running Windows applications in enterprises, and Docker was never even a factor in that. And now with the fact that, I mean, we could hack Docker to make it work, but just the fact that the new operating system from Windows is having native support is a big, big deal. And it's really going to change how we think about it. So in terms of why this is so important is because it's the abstraction layer in terms of how developers think. I mean, today the DNA required for building non-Windows applications like Linux and any other kind of platforms and Windows applications is radically different. There's a big demarcation between those two. And the ability to kind of use a common tool set, common tool chain in terms of how you represent your applications and how you package them, how you deploy them, becoming all standard is a big deal. And standardization is always huge. And that's one of the things, I mean, I've been looking at this, playing with alpha versions like back 1 year ago, but this is kind of cool stuff because it's not just a layer. They've gone and done a lot of things at the kernel level itself. And that makes it where, I mean, we had tried to do this. I used to work on Cloud Foundry. I don't know if anybody's here from Pivotal Labs, but where we used to kind of create application pools and try to mimic this kind of isolation so that we can run multiple applications on Windows platform, pretty much net-based or HTTP-based applications. But this can now go into much, much deeper. And I'll talk about what the big advantages are. So, of course, I have a not so good also, but the good part, let's talk about the good part. The first thing is native support. Absolutely, it's just going to run part of the kernel itself, so you can't run any Docker command. As I said, it's kernel level containerization. Everything that happens in Linux in terms of C groups and JLs and all that stuff is app armors and things like that can all be implemented on Windows also now. The big thing is the semantics are exactly the same. It's nothing different. If you already know how to use Docker run, you'll probably know how to do Docker run on Windows also. So the big point I'm excited about it is you're completely abstracting yourself from the operating system at that point of time, from really the host operating system, and that's the big advantage. And it has full process isolation. It's not like some pseudo application pool or anything like that. I mean, anybody who has tried to use application pool has always struggled with the main problem of Windows account. I mean, I worked at Microsoft for 11 plus years. So the main problem we had, and I was on the Xbox team, was that your registry was shared. And the moment registry is shared, you're kind of screwed because you don't have ability to do anything with the registry. And with the 2016 version, you can get registry and files completely layered and isolated. So you can pretty much have 10 different registries if you have 10 containers running on a Windows server. Now that suddenly changes. It's kind of like, I don't know how many people here have tried with .NET. .NET versions, what version is installed, what version is running. I mean, it's just a nightmare. I mean, but the ability to say, I can have 2 containers, one running .NET version, whatever, 2.0 for example, another one running the latest and greatest, on the same operating system and not having any conflicts is a huge deal. I mean, that's the biggest advantage you actually get. I'm super excited about this. Even though Shippable works completely on open source, I'm still very excited about what Windows is doing right now. Another big thing I saw, I haven't dug in too much into this, it's super new, but what they have also created is this layer where it's called Hyper-V Lite, which runs, it's not just containerization, it's also like virtual machines that are actually running on top of Windows. So if you are worried about container security and you think VMs are still the much better way, it gives you the full isolation, Windows, I don't know if anybody really have paid attention to that fine grain, where the biggest advantage VMware had with Windows was that you didn't need an operating system at all to create virtual machines. Whereas with Windows, you actually had to install Windows first, and then only you can create Hyper-V on top of it. Now they are kind of leveraging this to their advantage, and now they've created a thin layer of Hyper-V on which you can actually run Docker containers inside a Hyper-V that almost is like a VM to container 1:1. So you get pretty much full VM isolation running on top of Microsoft Windows. And you can also have a Docker container right next to it, which is just running containerization. it's not doing any Hyper-V level isolation. That's a big deal. So you can kind of lift and shift pretty much all your applications that were running on VMs as VMs onto the Windows host machine, and also have Docker containers running in next to it. So you don't need to have all these different farms to actually make this work. That's a huge deal in terms of how you can actually evolve towards containerization. So that being said, those are all the positive things. From a negative perspective, what I think is this: you still cannot run containers that are built on Linux on Windows, or vice versa. I kind of caveat that with yet, but I'm pretty sure that they're going to figure this out. But the problem is that you're really still, your development methodologies are not unifying. It's still completely different on how you think about it. And this should be super exciting for operations though, because from an operations perspective, I don't care at all anymore, whether it's a Docker container built on a Windows platform, Docker container built on a Linux platform, it will just work. All my operation tools are exactly the same. So there's a lot of standardization for anybody who's trying to do DevOps and stuff like that, where they're finding challenging. This is kind of super useful. But this is, again, as I caveat, I don't know the roadmap of where things are going, but I personally believe that this is going to happen at some point in time in the near future. Maybe Windows 2019, I don't know, but I'm just saying that's the big challenge. So with that being said, that's the biggest exciting part of Docker. I want to talk about what we do at Shippable and how we think about this entire thing. Just to give you a quick background of what Shippable, we started this back in 2013. Manisha and I, we both were working at Microsoft. We saw a lot of challenges in terms of deployment, especially with Kinect. I was on the Kinect team. We were deploying 25,000 servers at that point in time. It was like very difficult to kind of get this thing going. And I stumbled upon this thing called .cloud, and I kind of said, if you kind of think about this as a solution, and if you kind of build the image first as opposed to building it last, then suddenly the world of development changes, hence this should be what we should be working on. And we started the company back in 2013, February. Docker went fully open source, I think in April of 2013, and we were actually using internally how the Docker was. They had this big, bold thing saying, do not use it for production. And the first thing we did is use it for production. And we said, it is too good for us to be in there. So we started running 10,000, 20,000 containers a month on this layer of 0.16, I think that was what Docker was at that time. And we currently have about 75,000 users, 8,000 plus organizations. This is all on our SaaS platform. And what we kind of started doing is continuous deployment is going to be big. We got to be focusing on that. And at that point, people were still thinking about CI and that kind of stuff. So we looked at it and said, hey, let's go build a CI platform based on Docker. And we'll try to get as much developers as possible, because eventually you need continuous deployment. That was our hope. And I think that's where we are seeing the market kind of go. So the question is, why do you need continuous deployment? So the first question is your business becoming software powered? And it's crazy. A lot of companies today that never thought that they would be building software have started to build software. And the reason is because IT typically used to be system of record. IT is becoming system of engagement. And that's the big departure that's happening. Before, all I needed to do is enter something that you made an order or you got delivered or something like that. Now it's all about interaction with the customer on an ongoing basis. So mobile, and especially what Tune is kind of trying to drive, all of that stuff, mobile is a big deal. Tablets, mobiles, all of these things means consumers or customers are interacting with your company a lot more frequently than what they used to. Before, the only software people wanted to build was filling up your warranty card on the internet and saving it, and that's about it. And there's nothing else they did after that. So that's the first problem. So if you say that that is happening, then the question immediately becomes, how frequently do you ship? Because if you're not updating your system of engagement fast enough, other people are going to do this, and you're going to be out of business. I mean, that's kind of thing. And it doesn't matter whether you're doing it 100 times a day, 20 times a day, 20 times a week, it really doesn't matter. What matters is, have you started doing this faster or more frequently than what you were doing last year? I mean, that's kind of the benchmark I would kind of like try to put it. If it took you 3 months to do it last year, is it taking you 2 months? And if it's not, why is it not, and what's the friction? I mean, that's kind of the definition of how I think about it. I don't want to kind of claim here, Shippable deploys over 70 times to production on a daily basis. That doesn't mean every single company should be doing this. I mean, that's not the goal that it is. It's about being faster from where you were. So if that's true, this is the biggest question. How do you feel immediately after a deployment or just before you deploy? Do you think the world is going to blow up? Or after that, can you sleep, is the first question. I mean, this is what you're really trying to get to, right? So the way I look at it, I don't care about what you do to make this better. The goal should be about, is this becoming better? Are you feeling safer and more comfortable about what you're deploying? Now, beyond that, where I really think the market is this. How long does it take before a new hire can do a production deployment? And the question becomes is, immediately after this, how do you feel again? That's the other question, right? So this is what the world is kind of trying to get to, because if you think every company is becoming a software company, that means the number of developers are not growing at exponential level. That means there's going to be a challenge in terms of hiring people. That means you got to be able to get people who you hire as productive as possible, as quickly as possible. I mean, that's basically what you're trying to drive. And so continuous deployment is all about this. That's about it. It's about predictable, repeatable, quality-based deployment and getting changes into production. I mean, that's all it is. So the way I think of it is a little bit different. So this is my question. This is where I say where you are in your continuous deployment maturity. Is your business team doing the release to production, or is your technical team doing it? And that's kind of how I think about it. Because if you really, the reason why this is so important is because technical teams should be completely absolved from deploying it into production. It should be more of a business decision. Do I want these features to go to production now or not? And technical team is working on whatever, vNext plus one, vNext plus two, it doesn't really matter. What matters is, can I just reliably just press a button and go to production? Now, I'm kind of pushing this envelope a little bit, but at least at Shippable, head of product management, Manisha, my co-founder, is the person who does production deployment. Because she's the person who decides all of these pieces are in, so I'm going to deploy, and I'm going to try to push this into production. Even though you do continuous deployment, feature level branching, all of that stuff you could have done, but when does the customer actually see it is done by a business person. And that's what I mean by deployment from my perspective. So my kind of looking at it is that's the North Star that we are kind of marching towards. Maybe you'll never get there. I mean, it's kind of like the whole desktop on every single desk in the world kind of vision. So it's that vision that we're kind of marching towards. So with that being said, as I said, rapid innovation is super critical. If you don't do it, you will not survive. And hence, you have to do this, is kind of how our theses are. So the question becomes, hey, DevOps talks about all of this stuff. So the problem I see is DevOps does talk about all of that stuff from a principle perspective, from a philosophy perspective. It doesn't offer you a solution. And it doesn't say, I mean, it's kind of like saying, I want to buy HTML software. I mean, Notepad is what you need to buy if you need HTML software, right? And it's kind of like that. DevOps kind of gives you a whole bunch of philosophies that you got to do, cultural, technical, automation, whatever they are. but it doesn't offer you a solution. So you need something that makes this happen, and it needs to be built along with this philosophy. So if you look at software development, this is kind of what's happening. It's a very simple thing, code, deploy, run. That's all it is. And there's a whole bunch of stuff that you need to do on the coding side. I mean, this is just a very abstracted version of what really happens. There's a whole bunch of things that you do on the deploy side, and there's a whole bunch of things that you do on the run side, depending on what type of infrastructure you're using. Whether it's IaaS, PaaS, or CaaS, or serverless, or whatever you want to kind of think about it. So if you kind of push that, here's what's happening. So 2012 is where Git kind of started becoming the standard. A lot of companies are pretty much defaulting to Git. Nobody even thinks about anything else at this point of time. The same way, in the last 18 months, Docker is becoming a deployable unit. So if you think about it, whether it's bare metal, whether it's VM, whether it's PaaS, whether it's CaaS, whatever it is, I can package everything. Now it's Windows also. So Docker becomes a deployable unit. But if you look at continuous deployment, or the deploy part of it, there is 100 different pieces of software. And you need an engineering team to connect all these things together and try to build this thing of how do you deploy this to production. And what I meant by that is if you kind of look at all those layers, CI, CD, release management, service discovery, config management, scaling, all of these things, there is actually a company which is actually building this. And that's the crazy part of it. So what that does is you create this very fragile pipeline that is super custom. I call it bespoken, which is kind of like tailor-made for some particular scenario, usually built with a whole bunch of developers who know Ruby, and actually kind of created it. And the thing is, this was actually a scenario, one of our enterprise customers, the person who wrote a lot of these things left. They went and deleted his Active Directory account. Every freaking continuous deployment pipeline failed. And because they just didn't know where all this person's token was used, and now they don't even know where to change things because it's all over the map, because it's all embedded into the code. They actually recreated that account, got that person back in to update all the stuff, and then started to figure out what do we need to do in order to get out of this mess. I mean, that's basically what's going to happen if you try to create a bespoken model. It's a whole bunch of siloed tools. You lose fidelity. You have really no idea what's happening in one end on the other end, and that's basically the challenge. And of course, some tools are built for operations, some tools are built for developers, some tools are built for something else. Trying to create all of this common pipeline to do deployment means you have a lot of cultural mismatch. And that means you have really a challenge trying to get things to work together, because there's a skill set problem that you're trying to really solve. What you end up doing, or at least what I have seen companies end up doing, is they go to the lowest common denominator, as opposed to having a highest common factor, which in each of those areas that they can get the best possible person, they're kind of getting generalists, which becomes a problem. So that's basically the fundamental thing. So what Shippable is a common platform that does all of this stuff. Of course, this was a setup slide, and I completely get it. But the point is that what we have built is a common platform. Now, that doesn't mean that you have to throw out everything that you have done. If you are using Jenkins, you connect Jenkins into Shippable and it still works. And you can figure out whether you want to migrate or you want to continue to use Jenkins. If you are using some other kind of infrastructure automation tool, you connect that into it, fill up the rest of the gap. You don't have application release automation, it gives you out of the box. You don't have config management, it gives you out of the box. You don't have maybe secret store, it gives you out of the box. But if you do have it, you can pretty much connect to it. A lot of our customers already have some sort of CI tools. They connect the rest of the workflow into it. And that's basically what I'm going to kind of demo. So with that being said, I'm just going to quickly jump into my demo, and I try to do it as fast as I can. If you don't hear me, let me know. So, can you hear me? No? Yes. Yeah. Okay, cool. So I'm trying to speak up. So what I'm going to do is, this is Shippable. I mean, it's currently the SaaS version that we are talking about. So I'm going to jump into pipelines. And if you see this is basically a simple pipeline that we have on Shippable. So what it is showing you is there is some sort of a repository which gives me all the information about this pipeline. I'll talk about it. There is an infrastructure provisioning layer that is currently running Terraform. It could be running Chef, Puppet, Salt, Ansible, whatever you want to actually run. Currently, we are using Terraform. Then what we have is a CI process for a component microservice called DB, which actually creates an image, which is getting pushed as a manifest into a service, and eventually gets pushed to ECS as an actual live service. And all this is doing is it's a visualizer, which is talking to some backend database to see what services are getting deployed. And if I look at it right now, this is my DB, nothing is running, it's completely empty. And if I look at my container service on Amazon, I have two clusters, a test and a production, and my test cluster is running my DB as, if you don't see it, it's basically a service that's running. So I'm not gonna try to deploy this. Now, let's talk about how do we create this actual environment. So if you look at our test environment, everything is declarative. Can people see this? So this is the best I could do, but so I think what it is saying is I have basically two different files, resources and jobs, and everything is a resource, and every single resource pretty much looks identical. I mean, so you need to learn the syntax only once, and you just basically keep changing it depending on what you're really trying to do. So what this is doing is here, I have an integration called AWS demo where I'm creating a pen key. I have another integration for AWS demo creds, which talks to ECS. And I have a demo infrastructure repo, which contains my Terraform files, which just I run Terraform apply and actually brings up the thing. And then that's basically what you saw in here, this part of the stuff. Now, if I look at it here, now what I have is a credential for my Docker Hub. And if you look at this, none of the credentials actually exist in the YAML file. This is happening in a secret store that is centrally stored. So if anybody leaves, you just go update that one integration. Every single place where it's used is actually getting updated automatically. Now, I also have a repository for Git repo. I'm actually saying I want a branch master. My source name is AvinCDB. It's connecting to Git repo. But if you look at it, it doesn't tell you whether it's GitHub or not, because every Git repo is abstracted. Whether it's running on Bitbucket server, whether it's running on bitbucket.com, GitLab, GitHub, it doesn't really matter. The integration is what tells me how do I actually connect to it. And that's basically the integration of NCG Edge. I've named it so that you know it's actually GitHub where it's actually running. Now I've created an image. Again, image is a resource. It doesn't tell you whether it's running on ECR, GCR, Docker Hub, Quay, doesn't really matter, or private repository, because you're just creating abstractions of all of this stuff. And I'm just creating a seed version of .7. This is the starting point of my entire workflow. I'm creating some options on how my Docker needs to come up, memory, CPU, and there are probably about 250 different options that you can actually set. We don't care about what these are. These are just passed through into our endpoint, whatever target it is. And then what we've done is we've created a cluster here. And this is, the type is just cluster. It actually is running on ECS, and the integration tells me it's ECS. And my source name is test AWS, and that's basically this here. So that's kind of how you set up your pipelines. So whatever you saw visually there was all represented through YAML, and it was created that way. Now, if I jump into my jobs, the whole thing is set up in a very simple dependency format. So what is my input, what is my output, and what am I going to do when success or failure occurs? And that's as simple as that. So if you look at how this is a shell command that's running, since it's Terraform by, actually, this is build.sh, which is actually running Terraform apply internally. All of this is open source, you can see it. And there is a CI job that's running. Now, it could be anything in the world. You can run any kind of commands here that actually run on the machine. I've created a manifest, which is actually the service definition. And the way I created service definition is I inputted the image, and I actually also added the Docker options into it, which is basically what this is, and that is creating the manifest. And the beauty of this is, as you move through your pipeline, you can override these things from test to dev to production, or however you want to think about it. Now I have a deployment, and if you look at it, there is no AWS run.json creation, none of that stuff exists here. All it is I'm just saying, here's what I want to do. The product internally is actually creating all that stuff for you and pushing it to the target. I mean, that's basically what's happening. That's how DB came up. Now what I'm going to do is I'm going to quickly run a service that is going to draw a box and put it into my dev environment. That's basically all my system does. So I'm going to just quickly do it. So if you kind of look at it here, the things that are commented, I have a repo, I have a box image, I have a whole bunch of environment variables here. There is secure environment variables which are encrypted for passwords, and then I have a Docker option. So what I'm going to do is I'm just going to uncomment all of this stuff. So whether you're running infrastructure, whether you're running Docker containers, CI, the syntax looks exactly the same in terms of what it is, and there is no if, then, else kind of looping or anything here. It's just declaring what you really actually want. And then on top of it, I'm also going to uncomment all of this stuff. And it's pretty much the same workflow, run sh, deploy, and I'm going to just push this to Docker, push this to GitHub. So I'm going to just do a git push, and if I jump back here, you should see the test pipeline. Hold on, let me just refresh. Yeah, there you go, it started running. So what it's doing now is it realized that my definition of pipeline repo changed, and it actually went and interpreted it, and it actually gave me the entire pipeline for box, which is there is a CI job that's running here, then that creates an image, which is getting created, pushed into a manifest, which eventually is going to get pushed into box.test. And after test finishes, I run an end-to-end functional test platform in order to make sure that my deployment actually worked. And that's basically what the workflow is. And all of that was done through that YAML. There's nothing in the UI that you can actually do. You can just actually see what's going on from an end-to-end perspective, and as I show it. So what I'm going to do is, instead of committing to box, I'm just going to right-click for now and say run this. So this is basically assuming that there's a git commit that happened on the back end. I'm going to run through CI, create a new version of the image, and what this version is going to do is create a green box in my test environment and push it to AWS, that entire workflow. So whatever you saw as the declaration is the total code required in order to do all of this and push it to AWS. So this should take about, if you see this, it's provisioning some nodes. While it's running, it's going to provision some nodes on AWS. We're using backend AWS infrastructure. You can use pretty much anything you want. Currently, it's using AWS. That's how it's set up. So it's going to run through this entire workflow. And while this is running, what I'm also going to do is I'm going to put on my operations hat right now, or a business hat, and say, you know what, I want to do release management on top of this. So the way we do security is it's completely source code based. So you create a new repo, which only people who have access to production have access to, and all of those credentials are set up there. So what I'm going to do is I'm going to enable that repo while this is running. So enabling the repo is super straightforward. Before that, let me just jump into my prod repo, and I'll just show you what exactly I'm doing here. I'm going to uncomment this. So if you look at it, what I did is I created a release management with a version. I have a production cluster, which is different from my test cluster. I'm creating some parameters where my environment is changing from dev to test to prod. And I also have a scaler, which gives me the number of replicas I want to run on production. So you could potentially come and just change these scalar numbers, and you can even write a script internally to figure out what your load is to change this dynamically, which will actually run through entire auto scaling up and down. And that's basically what I did. And now what I'm going to do is I also have a couple of triggers. So if you don't like deploying things from the UI, you can actually just use these triggers to deploy, which is just a trigger that goes in. And I also am going to uncomment the deployment and release into production. So if you kind of look at this, the only thing the release occurs is, it's not really talking about any of those definitions, because all those manifests have already been created, and an immutable version of that has been stored and created as a release. So your production deployment is just basically pointing to that release that was done, assuming your tests actually pass. So I'm going to walk through that entire workflow. So this is basically what I'm doing right now. I'm going to commit this. So this thing should have started running by now. So this is starting to run a whole bunch of CI tests and everything. I mean, I know it's hard to read this, but you basically get console output directly live from the actual container that you can actually see what's going on. So while that's happening, what I'm going to do is I'm now thinking like a business person now. I want to create a release on top of it. So what I'm going to do is I'm going to add a resource here, use my GitHub integration to create the first. So the first seed repo always is done through the UI with permissions, and after that everything is done through the UI. So you saw my prod repo that I just changed, and I'm going to pick that prod repo here. Oops. Okay. And then I'm going to pick master, and I'm going to call it prod ops, and I'm going to save it. So what it is going to do now is it's going to create all the integrations that it requires with GitHub and webhooks and all that stuff in the back end. And then if you look at the thing, it actually is going to run my prod sync right now. And as you see this is starting to run. So my test AWS deployment has started happening. So if I go back to my visualizer now, you should actually see this thing draw a box with a test environment, which is basically what I'm trying to demo here. Just want to make sure that I'm good on time. So there you go. So it's a single replica green box that got deployed to test environment. And it's currently basically polling backend ACS and figuring out what actually is running, and that's how it actually got this. So you should see that that's run, but because I actually deployed into test, an end-to-end test functionality is starting to run. If that passes, then if you look at what we just now did, is we added a whole bunch of production deployments. So this thing passed. It's a simple test. It just checks whether the color API is there or not. You can write it as complex. You can make it 10,000 tests if you really want it. So now what I've done is this test ran, but it's dotted line because I don't want to automatically do a release because this is only owned by business person. So this stopped, the workflow stopped right now. But I can actually, as now I'm thinking like a business person, I have this whole thing. If I create a release here, it's going to create a brand new release, take the current state of what was in test, package all of those container versions, create a manifest, and push it into production. I mean, that's basically what's happening. Of course, you can make this also dotted line so that it doesn't automatically do it, but I'm just going to do it as automatic right now. So assuming I'm a business person, I'm going to right click, hit run, which means I'm actually doing the release right now because I know what is the current state of my test environment is good and everything tests passed, hence I'm going to do a release. So box release is running, so it's going to create a release with semantic versioning, and I'm going to show you the release job exactly what it did. Now it started doing a production deployment because this is automatic. And if I go back here, now, oops, you should actually see two containers come up with the same green box and end-to-end everything. There you go, production AWS came up. So I got these two things running. So I got end-to-end pipeline all the way from source code to production. Now that's not enough. I wanted to do disaster recovery and I wanted to be on a completely different cloud. So what I'm going to do is I'm going to set up a GCE cluster quickly, and I'm just going to run that right now. So this is just a simple command to run GCE cluster. It's going to bring up a new cluster. So if I run this, it's going to start creating a cluster. If I go to GCE, you will see that there are no clusters right now. If you go to AWS, and I'll refresh this. If you see this, this had only one service, which was DB. You actually see a test version of my box running here now. And I also have a production version of box with two replicas that are running. And if I change the replica count, it will just come and update it, and you will get 3 replicas, 1 replica, whatever you want. You can create dynamic scaling without actually having to do anything from like a rocket science perspective. So if you look at it, I didn't write any bash scripts, I didn't write anything, I just basically declared a whole bunch of YAML, and I got end-to-end pipeline set up in a matter of like few minutes. So while I wait for this to run, so it's creating the cluster. While it's creating the cluster, I'm going to now create a DCE, disaster recovery GCE endpoints. So I'm going to go into this here, and if you look at it, I'm just going to create a job to deploy to GCE. GCE. And if you look at it, this job looks exactly syntactically the same as this job. Both of them are deployed. One has an automatic trigger. This one just basically is looking at the parameters and pushing it into GCE. And the difference between all of this stuff is what is my input cluster. One is inputting a GCE cluster, other one is inputting an AWS cluster here. And the way I define that is in my resource YAML. Here is my definition of my DCE cluster. And I also want to have a new environment variable to show you it's actually running disaster recovery in that cluster. So that's basically all I did. So I'm going to just commit this while it's provisioning. Oops. Push. So if I go back to my pipeline here, let's go back to this pipeline. Let's look at the whole thing. So it's syncing. I was thinking that that's going to happen. Sorry, it's still working. I want to put it in my pocket next time. That's the disaster recovery. So anyhow, so it synced up, and if you see what it did is it actually created a parallel deployment to GCE, and it created the same exact pipeline. Now, what I'm going to do is I'm going to wait for GCE to spin up. I think it should spin up. It should not take too long. Let's look at and refresh this. So yeah, it's starting to come up. But basically, the idea is that the same exact syntax, the same exact pipeline, the same workflow, you can actually push to GCE with having to not worry of deploy.json now, which is a completely different format from Kubernetes perspective versus AWS run.json. Now it's not just that, you can deploy to Mesos, you can deploy to OpenShift, you can deploy to Azure Container Service, you can deploy to Kubernetes running on premises, you can deploy it into just bare metal machines like CoreOS or anything like that. It's exactly the same syntax. And so what it gives you is, okay, this thing finished. I just want to verify it finished. Yep. So what I'm going to do is I'm just going to run this deployment. You can of course use the trigger in order to do it from the repository, but I'm just trying to short circuit it. So this is going to run now. It's going to deploy, and you should see another environment here come up with GCE. So I'm just trying to hurry up. I'll switch back here, but I want to get back to my slide. But that's basically the deployment. So what you guys just saw right now was an end-to-end pipeline going from all the way to Git repo to deployment into a container service. You can also do this for non-container based workflows, whether it's a jar file, it is still an immutable version, so we can deploy that. Whether it's a binary file, you want to copy some Go binaries into machines and start that up, it matters. It doesn't really matter. You want to run an upstart job, you want to run a cron job, whatever you want to run on that machine, it's a cluster for us. It's a cluster of one if you're doing single deployment. If you want to do multi-deployment, it's a cluster of 5 machines. The only thing that changes for us is whether that cluster is actually a set of VMs, or whether it is a set of physical machines, or whether it's a cluster on AWS, Mesos, wherever it is. And eventually, it's also the same thing with Lambda. So if you've written a whole bunch of functions that you want to push to Lambda, the same pipeline, no change. All you do is change your integration. It's still a deploy. Change your integration into AWS and Lambda, and you can push to Lambda, exactly the same workflow. The magic of all of this is the declarative YAML. So we built this entire framework where you can represent all your deployment actions as YAML blocks. You can call it macros, you can call it whatever you want to call it, but you don't need to write 20,000 lines of code behind it in order to make all of these things work. Now, there is a run sh, which will allow you to run any shell commands that you want to run the way you were running it before, but that really is not what we want it to be. We want it to be where you're using more managed tools like deploy to AWS, deploy to GKE. And the reason why we have run sh is we totally understand that people have a lot of things that we don't support, so you should be able to run through run sh. And while we figure out what features that we should be building into the platform on an ongoing basis. So this is kind of like how we think about it. And the most important thing about it is it's completely scripted. So you get full auditing capabilities. You know who changed what got changed in the system. And you are basically saying it, a lot of our customers have this thing called trace, where they actually want to trace and figure out what happened in the last 1 week on their production environment. I mean, that's basically what the fun power of this is. So in terms of industrialized, we call it industrialized continuous deployment, because this is kind of going towards the Toyota world of Jidoka, where if you look at how the UI looked like, it was all about giving you, don't worry about what's green, just worry about what's red. So I'll show you quickly Shippable's pipeline, how it looks. It looks pretty hairy because we run over 50, 60 plus microservices to actually run our service, but you can actually see how complex the pipelines can be able to actually run. That's the first one, which is CI, CD, ARA, secrets, all of that stuff is baked into a single platform. You can always use whatever you're using if you have already invested, but it is still a single platform. It's a future-proof platform. Whatever version, whether you're running old jar or binary MSI-based deployments, or whether you're running Lambda, the same exact pipeline actually works. And the most important thing is, from an operational perspective, it gives you end-to-end visibility. What exactly is happening, where things are stuck, what should I be focused on, and how do I do release management and deploy things into production without having to be a big 2-day ordeal where everybody is working 24/7 in order to actually get this deployment going. I mean, that's basically the philosophy. So with that being said, Shippable is available as SaaS, hybrid, and a server. So SaaS is completely free to use. You can be wherever you want. You can be on hybrid. A lot of our customers say we don't want to run www, we don't want to run all your UI pieces, but all our source code, all our machines need to be behind the firewall, but I don't want to run any of your service. That's a hybrid model. Some of our customers say we want everything. I mean, we want everything for ourselves. We don't want to share nothing. And that's basically from that perspective. And that's basically what pretty much what I had. So let's just quickly jump here. There you see GCE actually came up, and you got pretty much prod, test, GKE, all of it running on a single common platform. The pipeline looks something like this now, which is a fully built pipeline end to end. You can go, I mean, you can kind of see the whole thing here. And I just want to quickly wrap up by jumping into how Shippable runs. So we use our own platform to manage our own business. So most of the features here are built for us and pretty much what everybody else could use. So if you look at our pipelines, don't be worried. It's a bit hairy, but it's going to take a little bit of time because there are over 500, 600 plus objects. So this is our pipeline. This is how we run all of our stuff. We run monorepos. From monorepos, we create images. From images, we run microservices. So there is a server branch that is getting deployed. There's a SaaS branch that is getting deployed. There's a whole bunch of stuff that's happening. And if you look at it, my only job is super easy as the kind of like the CEO of the company. All I need to do is in the morning, I look at this, and I know whether everybody everywhere in the world actually did what they were doing, or they did nothing, because yesterday's green is still green. And so either they did very good or they did nothing. So it's easy to manage those things. So that's basically all I have. So with that, I mean, I'm of course here around. If you have questions, I'm more than happy to answer. I want to keep this thing going because we have a long night. So with that, I'll invite Nick over to do the next presentation. Thank you very much. Appreciate it.